Welcome back, everybody. Today's topic is 3.23. This will be part 2 of it. So with your team, or in this case by yourselves, examine the equation you wrote for parts B, C, G, and H from problem 397. This pattern is the simplest form of what mathematicians call the distributive property. Multiply the following expressions without an area model to write them as sums instead of products, and then so pretty much what you want to do is just again the strip property means like everybody like you're making sure that everybody's getting some, right? So here we want to make sure that we multiply both the 2x times the 6x and then also times the 5. So 2x times 6x gives us 12. And then again, remember when you're multiplying variables, you just add the exponents if it's the same variable. So that gives us x squared. 2x plus times positive 5 gives us positive 10x. That's pretty much we're done there. Same thing for part B. So again, this root property, multiply both the 6 into what's inside the parentheses. So 6 times 4x gives us 24x. 6 times negative 1 gives us negative 6. And then this would be equal to part C. So we have x squared times 4x times negative 2y. So x squared times 4x gives us 4, right? 1 times 4 is 4. X squared times x gives us x to the third power, right? This one has an exponent of 1. And then x squared times negative 2y, that would be negative 2 x squared y. And then part D, so we want to distribute the 7y's, so we're going to multiply both times the 10x and the 11y. So first the 7y times 10x gives us 70, and then y times x is just xy. 7 times 11 gives us 77. And then y times y gives us y squared. And then does order matter when multiplying polynomials? So investigate the following questions. So are x plus 1 and 7x plus 1 and 7x plus 1 times x plus 1 equivalent expressions? Justify your answers with the area model, right? So again, this goes back to knowing the properties of multiplication, right? So here, if we do multiply this, so x plus 1, and then we have 7x plus 1 here. So that would be 7x squared plus x, and then plus 7x here, and then 1 times 1 is positive 1. So that gives us 7x squared plus 8x plus 1. And then we're going to do this one. So we're going to set it up differently. This time I'm going to put the 7x plus 1 on the side here, and then I'm going to put x plus 1 on top. So 7x times x gives us 7x squared. 7x times 1 gives us 7x. 1 times x is x. 1 times 1 is 1. Combine the like terms, and that would give you 7x squared plus 8x plus 1. So if you guys notice, I get exactly the same results, right? And again, this goes back to properties of multiplication, just a simple property of multiplication, knowing that 6 times 8 is equal to 48. And I know that 8 times 6 is also equal to 48, right? So it's the same thing here. We're multiplying two things, two factors. The order shouldn't alter the product. So our x minus 1 times and then 7x plus 1 and 1 minus x, 7x plus 1 equivalent expressions. So again, in this case, be careful because we do something changes here, right? So you guys see that? So let's check the first one. So that's going to be x minus 1 and then 7x plus 1. So that still gives us 7x squared, positive x, and this would be negative 7x, and this would be negative 1. Positive times a negative is a negative 1. So here it gives us 7x squared, and then negative 7x plus x gives us negative 6x, and then minus 1. And then let's check the second part right here. So we're going to put 1 and then negative x. So this one, the x is negative, so be careful there. So 1 times 7x is 7x. 1 times positive 1 gives us positive 1. Negative 7 times negative 7x would be negative 7x squared. Negative x times positive 1 gives us negative x as well. And again, combine the two like terms. We're going to get negative 7x squared plus 6x minus 1. Oh, plus 1, sorry. So here, if you guys notice, again, the order of the numbers inside does matter, right? So we cannot flip those. So you guys got to be careful. You got to make sure that when you line them up, you're always doing the same way, right? And then here, which expressions below are the same? So in this case, x minus 5 times 2x plus 3. And again, if you guys notice, these two, 1 and 4, are the same. They're just in different order. And then you have 2x minus 3 times x plus 5. 2x minus 3. I don't see no 2x minus 3 there, so no. Negative 2x plus at 3, and then x plus 5. So negative 2x, also not in there. And then negative x plus 5, and then 2x plus 3. So these two do have the same one, right? And then 2x plus 3. And then that's it pretty much. I don't see anything else that might match up. All right, and then let's look at the last part right there. Write the entire area as a product, and as a sum, be prepared to share your reasoning with the class. So here, x times what gives you xy. So for sure we know we need a y there, right? And then this should be 3 on top right there. I'm assuming just 3. So therefore we would say this is equal to x plus 3 times y, or y times x plus 3. All right. So you're trying to figure out in part B, what two factors give you x squared? And I know pretty much, for example, x times x gives us x squared, right? So we're going to put that down here and up here. And then what two other factors give us 12x? So pretty much 12 times x would be the only two things, right? So let's fill those out. And then here we're going to multiply. 5 times 12 is 60. And then 5 times x is 5x. So we're going to write this as a product. First, we're going to do x plus 5 and then x plus 12. Remember that if you have x plus 12 times x plus 5, it's still good. It's still the same thing. And this is equal to x squared, and then combine the two like terms, plus 17x plus 60. All right, let's do the same thing for the last problem right here. So first we have to figure out pretty much what are we missing, right? So I know for sure that here there should be, if I have negative 3y here and negative 3xy here, that means that there should be an x here. All right. And then let's try to figure out what's a common factor between all these numbers. And if you guys notice, all of them are negative and all of them are even. So we can factor out a negative 2. So let's put minus 2 here. So then I can start figuring out what number goes at the bottom here. So negative 2 times what gives us negative 10? That would be positive 5. And then negative 2 times negative 3y would be positive 6y. Negative 2 times what gives you negative 4x? And that would be positive 2x. And then lastly, negative 2 times what gives you negative 2 would be positive 1, right? So here we can keep simplifying. That's going to give us on top 5 times x gives us 5x, and then 2x times x gives us 2x squared, and then 1 times x gives us x. And then let's write it as a product, so that will be 1 plus 2x minus 3y plus 5, and then times x minus 2, and that equals pretty much to do we have any like terms? Yes, we do. This is a like term with that one. And then these two are also like terms. So let's say, and this one too. So x minus 4x gives us negative 3x plus 5x would be positive 2x. And then plus 2x squared and then minus 3xy, and then plus 6y, and then combine the negative 2 and the negative 10, that would be minus 12.